Everybody, Dr. Laura Rahala here from Mechanical Engineering Department. I've got Winnie with me again, and he's looking a little scruffy. She's due to get a haircut in 2 days. So see her face? It's kind of long. Okay, so today we're going to be talking about aerospace engineering. Let's put Winnie back over. She has this awesome area behind me. We've got this whole area to roam behind. She likes her black bag a lot. Okay, so back to us. Today we're going to be talking about aerospace engineering. So let me share my screen. Okay, so now my screen should be sharing. And okay, let me go full screen on this. Wait. All right, there we go. So this is the Department of Mechanical Engineering, and our aerospace program in the college is the college's newest program. It was just approved just a couple of months ago. And fall 25, which is when this is being recorded, that this is the first semester that we're offering aerospace engineering. So you might think, why is it in mechanical department? Well, mechanical is commonly a home for aerospace programs because they're kind of closely linked. And so we will probably be renamed the Department of Mechanical and Aerospace Engineering. We'll probably call it MAE department. But that's going to take a couple of years because with big universities, there's always like tons of red tape. All right, but this is where you can find aerospace engineering. Before this, we've just offered it as a minor, but now you can do it either as a minor or you can get your degree in aerospace engineering. Okay, and I'll go into more details about that. So this is what I'm going to talk about today. I'm going to talk about what it is, why it's important, the societal impacts, what we offer here at KSU, majors and minor. And then we'll talk about an example of a senior design project so you can see like aerospace in action here, like at the university level, careers in aero, salaries in aero, pretty good salaries. Aerospace engineering in Georgia. So if you're from this area and wanting to stay in this area, it's going to be very relevant there. Georgia is huge in aerospace engineering. Then we'll talk about employment internships and co-ops, student organizations, and finally the facilities, kind of really great facilities here at KSU. Okay, so let's get started. So what is aerospace engineering? So obviously, I think you guys know this. It's the engineering field focused on designing and flying vehicles in air and space. So aerospace engineering is always divided into two main branches. You have aeronautical engineering, which is when you're flying within Earth's atmosphere, and astronautical engineering when you're flying beyond Earth's atmosphere in space. So difference in aero and astro, kind of a difference of altitude, you could think of it. So we offer two concentrations in the major. So if you do the aerospace major, you'll select one of the two concentrations. If you do the minor's not set up in concentrations because there's only 5 classes. But if you do it as a major, we have these two concentrations. Okay, why is it important? Well, obviously, global connectivity. Airplanes make fast travel possible, linking people, goods, and cultures around the world. All of aerospace has made the world a much smaller place between that and communications. Telecommunications, it's just much smaller than it used to be, which is wonderful. Defense. Advanced aircraft and defense systems safeguard nations and offer global stability. And then space exploration and discovery. Rockets and spacecraft unlock mysteries of the universe. It's also an innovation engine. Aerospace breakthroughs drive progress in many industries. There are so many things that we, like today, take for granted, and we don't realize that the origin was through aerospace engineering, often defense contracts, defense needs. Originate a lot of the technologies that we take for granted today. And then economic and societal impact. It creates high-tech job, it powers international trade, and inspires the next generation of scientists and engineers. Okay, so let's talk about the societal impacts of aerospace engineering. So aerospace engineering, it requires excellence, as do all engineering and engineering technology jobs. This is not these are not easy majors. The entire college is not full of easy majors. If these were easy, everybody would do them. And the reason that you'll find the major is more challenging, the expectations of your professors are higher. Maybe you think some of the policies seem rigid, like the homework policy, for example. You might think, hey, that seems kind of rigid that we don't accept late homework. We are getting you prepared for working in the profession of engineering or engineering technology in this class. So with aerospace engineering, it's the societal impact. Well, you need to think about the safety of lives. Even small mistakes can endanger crew, passengers, and people on the ground. And really, this is true of all the majors that we offer here in the college. And so that's why they are all they're professional programs. They're restricted to students who can do the work, because if you design, if you like screw up some sort of a gasket, or let's say some sort of widget that's on an airplane or on a car or on even a chair, if this breaks because you didn't do good engineering, even if my chair were to break, think about what would happen to me if I fell down, probably like it's about 2 feet, if I fell straight down 2 feet because my chair suddenly broke. Well, first thing, of course, I'd go on a diet, but other than that, think about the injuries. I could hit my head on a table. You could actually be killed. I could break my spine if I went down and had a bad landing, going straight down 2 feet. So safety of lives is important. And that's also obviously important in aerospace engineering. So I'm just listing it first. High cost. Failures in aerospace waste millions or even billions of dollars in research, manufacturing, and launches. Mission success. Space and flight missions have one shot. Failure means lost opportunities. If you are on a mission, and let's say you're working for SpaceX, some of our mechanical engineering students go to SpaceX. I'm sure our aerospace students will as well. Or say you're working at NASA. You often just get one shot if what you're designing is supposed to, let's say it's supposed to meet up with an asteroid as the asteroid is passing Earth and getting data on this asteroid. Well, there's only one shot, and if you don't do it well, the aerospace engineering, the mission can be completely a failed mission. Okay, public confidence. People need to feel safe getting on airplanes or trusting space missions. Chain reactions. Okay, this is another thing that seems especially pertinent to aero. You can have one failure that damages other systems, vehicles, or infrastructure. And in aero, things are always going at a high speed and altitude, and there is a fuel need. And so it can go kaboom. So yeah, there can be a chain reaction where that little widget that you broke, unlike my chair here, which could cause injury, it can cause an entire vehicle or infrastructure to explode in aerospace. So it needs to be taken very seriously. Excellence required, great challenges need great talent. All right, so aerospace engineering at KSU, the major and the minor. So let me talk, before we get into this, let's talk about the majors and the minors. Okay, so a minor, and I think that another professor will be talking about this more in depth when you have the robotics and mechatronics engineering. I think they'll talk about this in more depth. But a minor is 5 classes. And in most programs, 2 of them are already tech electives. So it ends up being just 3 extra classes. If you had AP credit, you might easily, or a transfer student might easily have room in your schedule to get these 3 extra classes in and not even affect your graduation date. But what do you want? Do you want the major or the minor? And there's a couple of these where we offer both the major and the minor. So you can get a minor in mechatronics engineering, so robotics. You can get a minor in that, or you can get your entire degree in it. Same thing with aerospace. You can get a minor in that, or you can get your entire degree in it. The other engineering minors that we have are nuclear. Let's see. So it's aerospace, mechatronics, nuclear engineering. That's kind of an interesting story on nuclear, and biomedical and environmental. Those are the 5 main. Don't think I'm missing anything. Those are the 5 major, 5 biggest minors that we have here that work with engineering. Engineering technology also has minors in design and graphics and manufacturing, among maybe other areas. But if you're in like mechanical engineering, you can't have an MET minor count for your 2 tech electives. So that would end up being 5 extra classes, just something you need to consider. So let's talk specifically about aero. So do you want to get, like, say, mechanical engineering with an aero minor or an aerospace engineering degree? So if you have an aerospace engineering degree, you have a depth of knowledge that might be just what the company's looking for, just what you want in your career is this depth of knowledge. Your knowledge will be more narrowly focused, but it'll be deeper than if you were to go, say, mechanical, or I guess you could maybe do another major with an aero minor, maybe mechatronics with an aero minor, possibly electrical. I'm not sure. You need to talk to those professors. But if you went with with a major and the aero minor, say you did mechanical and aero minor, you're going to have all the breadth of mechanical engineering with a depth component in aero. The depth component is not as deep, but the breadth is wider than if you just did aero. And the same is true if you did mechatronics versus an ME with mechatronics minor. And there's no right or wrong answer. There's advantages and disadvantages to both. So you just need to figure out what is best for you. What do you want for your career? I am, a mechanical engineer. In the ME video, I talked about some of my background, but I really, really strongly considered aerospace engineering. And I wanted to go to the Air Force Academy in Colorado Springs. That was my goal. And I even got, your senator from your state, your US senator from your state, you have to have an appointment with them because they send the students to, you have to go through them to get into the academies. And so I even had my appointment all set up with my senator. But then I was thinking about it, and I remember talking to my parents about this, and my dad especially. He was very concerned that aerospace engineering the employment is cyclic in nature. And this was like, I was making this decision back 85, so it was like 40 years ago. God, it doesn't seem like that long ago. It was like 40 years ago. And so back then, the aero was largely connected to defense contracts. And the defense contracts were cyclic because the Republicans would spend more, the Democrats would spend less. The Republicans would spend more, the Democrats would spend less. And so it seems like there were cyclic, like huge layoffs that went cyclic. But that's really no longer the case. Kind of as of 9/11, there has not been this huge swing in the defense budget. I think the defense budget just kind of went up and up and up. So, but you have not seen those huge swings. So if you have somebody tell you that the jobs in aerospace engineering are cyclic, related to the government, I would, of course, listen politely, but between us, that's kind of old thinking. That's really not the case anymore. Of course, nobody can predict what's going to happen in the future, but in fall of 2025, that's not really the case. So don't worry about that. And you might very well have like a parent or a grandparent who has this older thinking about the employment. And also, something I know my dad was thinking is when Boeing shut down their supersonic program in the 70s, they laid off like 30,000 engineers. It was just this staggering amount of engineers that were laid off. And there was a sign that's in Washington State. There was a sign in the town, it was near Seattle, said last one out, turn off the lights, because it just seemed like Boeing was laying everybody off. But it was they closed their supersonic, and so they had to make an adjustment with that. Of course, now the big thing for aerospace has been the privatization of space. Really, I mean, kind of who saw that coming? I certainly didn't see that coming because throughout most of my life, it's been NASA, and it's been a federal government type thing related to defense and other things. So yeah, the privatization of space, that's really changed the outlook as well. Okay, so it's not as cyclic, so don't worry about that. The number of jobs that they are not as cyclic. And also, do you go with the major or do you go with the minor? It's a personal decision. There's no right answer, there's no wrong answer. But I'll talk about what we offer both in major and minor. So the in engineering we follow ABET, and I think I mentioned this in the last video about mechanical engineering. ABET is the Accreditation Board for Engineering and Technology, and they set the content and depth to which topics are taught in all engineering programs, accredited engineering programs, really around the world. And so our aerospace engineering program is typical of other aerospace engineering programs. It's not that we're copying the other six. I mean, I guess kind of we're inspired by the other successful programs, but it really comes down to ABET and what's required knowledge to be able to call yourself an aerospace engineer. And the reason that ABET does this is because engineering is an important field where the safety of lives and also property are largely related to what engineers do. This is why there's this accreditation board. Okay, so the major has 120 credit hours. There's the 2 concentrations. I'll talk more about that in just a second. The first 2 years are almost identical to mechanical engineering. The difference is you will take a class called Intro to Flight. And I can't remember exactly what the prereq is to Intro to Flight. It's either Calc 1 or Calc 2. It doesn't have a huge math prereq. It's either Calc 1 or Calc 2. Begins in fall 25, and it's only open to first and second year students. So we're not offering right now the junior, senior aerospace classes right now because we're ramping up the program. So we are offering freshman and sophomore classes. So it's not good for transfer students who want to transfer in like as a senior, but we're not accepting that. But the program, each year, the program will be expanding, of course. It blends theory, hands-on learning, and a year-long senior capstone, as most of the programs require a year-long senior capstone. Okay, so the core impacts, that's 42 credit hours. Those are the core classes that you need to take to be considered a well-educated college graduate. There's going to be your core field of study, then your major requirements, your major concentration requirements, your major electives, and then you'll also take a math and science elective. By the way, on this math and science elective, don't just willy-nilly take a class because it would count. Like maybe you could take biology. I mean, biology is a great class, but it would not make sense. That's not going to be useful information for you for your math and science elective. I tell the ME students to take linear algebra. Maybe, did I mention this in the last video? I might have. Sorry if I'm repeating myself. Linear algebra is a great class for mechanical engineering students. It's matrix math. I think Calc 2 is the prereq, and it's very useful. You need to know this information in some of the senior level classes. So on the math and science elective, it'll give you a whole bunch of options, but you're going to want to talk to your advisor about what is best for the aerospace major. And if your advisor doesn't know, then come to us, okay? Come to the department office. We're very friendly here in the department office. First floor of the Q building, engineering testing. Okay, now we're going to talk about the whole astro versus aeronautic. Okay, so aeronautic concentration. You will take an aircraft propulsion class and then aircraft and UAS design 1, 2, dynamic systems and control, and then systems and control lab. Okay, so you can see this is focusing on aircraft and UAS. So what's UAS? Another common word. Well, first of all, what's the acronym mean? And then what's like another common word for it? It means unmanned aerial system, UAS. Another word we call it is drone. And yeah, you have these like low orbit, really low orbit drones that are getting great shots of the football field, and we're getting really amazing video of football games and stuff, and aerial photography of all sorts. So there's that. But then also there's much higher orbit and defense related UAS as well. Drones. Oh, there's also the drones that are the weapons that are like being sent into Ukraine and so forth. So aircraft and UAS, design 1, design 2, dynamic systems and controls, and dynamic systems and controls lab after you take the aircraft propulsion class. All right, that's the aeronautics. In the astronautics, it's very similar. It's analogous. Instead of taking aircraft propulsion, you take spacecraft propulsion. You still take design 1, 2, dynamic systems and controls in the lab, but now it's for spacecraft. Okay. And they'll go into, advanced topics of spacecraft propulsion, like ionized propulsion and different spacecraft propulsion things. Use like a jet engine, for example, the propulsion in spacecraft. So at once you're outside of Earth's orbit. All right. So those are the differences. Now let's talk about the minor. So these are the concentrations if you do the majors. You do need to choose between one concentration or the other. All right. If you wanted to do the minor, it's 5 classes. Just like any minor, it's 5 classes, 15 credits. As I said, if you're doing like ME, 2 of these will already count as your tech elective, so it just ends up being 3 extra classes. So what you need to take is aerodynamics, and then you have to do the aeronautics design project. And then you can choose from 3 courses from this list of 5. You can do it. So choose 3. Aircraft design and performance, fundamentals of avionics, introduction to aerospace structural analysis, aircraft propulsion, and helicopter theory. So you choose the 3 you want. And avionics, that would be the electrical systems, electrical control systems. All right, so choose the 3 you want. So that's the minor. So that's what we have here at KSU. Now let's change subjects, and we're going to go through an example of a senior design project. So KSU's first AIAA, that's American Institute for Aeronautics and Astronautics. It's the huge professional society for aero. In mechanical, it'd be American Society of Mechanical Engineers, ASME. Civil would be ASCE. It'd be IEEE for electrical and computer engineering. So, but it's AIAA for aero. So they have this this competition. It's an international competition called CANSAT. And so we competed last year, and it has an autogyro descent and telemetry. It's collecting data as it goes. So we called ours OWLSAT. Make it customized for the owls. Okay, so if you look at the diagram here on the bottom right, so it goes up like a rocket, and it's a can. And in the can, you have the telemetry units, and also you have a propeller. So it goes up here, and then it starts descending, and the parachute deploys, and then the auto gyro deploys. And what the auto gyro is this is a this like a propeller. Now the propeller is not driven. It's not like an electric motor or solar motor, anything. It's not driven by a motor. It unfolds, and then once it unfolds, just the wind on it makes it start to spin. So it's using the aerodynamics, structures and design to make sure that the wing will start to spin, because not every shaped wing will start to spin. It's a very specific shape. So we did it for the first time this year, and we came in 5th in the country and 17th internationally, which I think is like darn good for somebody, for our school trying it for the very first time. So not only did they successfully get the project done, they also competed and did well, 5th in the nation. I have a video to show you of this. Now they did this as a senior design project. So I like it when a competition team is also senior design project. So it was probably a little bit more work than just your typical senior design project, and they had to travel to competition and all that, and have a fully working unit, just like the hydraulic bike team that I advise. But it's great when it's not 100% extracurricular. Okay, so let's watch the video.
Welcome to ALSAT, Kennesaw State University's first entry into the 2025 AIAA CanSat competition. Our mission? To design, build, and launch a fully functional CanSat, a miniature satellite payload engineered for a controlled descent, real-time telemetry, and onboard video recording. Here's how it works. The CanSat is deployed from a rocket at over 700 meters altitude. It begins with a parachute-assisted descent. At 75% of apogee, the payload separates from the canister, deploying an autogyro rotor system for stable, spin-stabilized descent at 5 meters per second. Throughout the descent, ALSAT transmits key sensor data, altitude, temperature, acceleration, and GPS, at 1 Hz, while 2 onboard cameras capture critical flight footage. What does ALSAT's design consist of? The centerpiece is a foldable autogyro rotor system, refined through 6 design phases using CFD, physical testing, and momentum theory analysis. A counterweight mechanism balances rotation, ensuring smooth, stabilized descent. Securing the payload during launch is a robust canister release mechanism, designed for precise deployment at altitude. Together, these systems, integrated with telemetry and video capture, ensure mission success from release to landing. ALSAT is more than a competition entry. It's hands-on aerospace engineering, advancing research in autogyro descent systems and preparing KSU students for real-world aerospace challenges. Thank you for following our journey.
That's pretty cool.
Delay generation for.
So that is the CanSat. I remember they were testing it in my lab. We have a research lab. It's a shared space. And, in order to test that propeller with the foldable blades, the auto gyro descent, all they had was just a fan. And just with that fan, which is simulates the wind resistant, kind of like a wind tunnel, it was just a large fan for this project. They were able to get that to fully deploy, unfold, and deploy, and work. There you go. All right. Now let's talk about careers in aerospace engineering. So you could be an aircraft design engineer where you create and refine airplanes, helicopters, and drones. Or you could be a flight test engineer where you plan and evaluate test flights to ensure safety and performance. Aviation systems engineer, develop avionics, navigation, and flight control systems. Aerodynamic specialist. And this is for aeronautic. I don't know if I stressed that. This is not for aerospace. This is for aeronautics. Aerodynamic specialist would optimize airflow for lift, drag reduction, and fuel efficiency. Or maintenance and safety engineer, which ensures the aircraft systems meet reliability and safety standards. So this thinking about flight test engineers makes me think of Glenn Allen, who was a professor here. He was a mechanical engineering technology professor. He was just amazing, this really, really cool guy. And he was a flight test engineer. And he unfortunately was diagnosed with pancreatic cancer. And I think pancreatic cancer is just really particularly nasty. And I don't think he lasted more than maybe 18 months from his initial diagnosis to death. It was very sad. But I remember talking to him once. We were talking about death and fear of death. And he said there was one time in his life where he really thought he was going to die. So he was working on the West Coast, and I think it was in the state of Washington, and as a flight test engineer. So he's not the pilot. You've got probably the two pilots, and he's sitting right behind in the cockpit, and he's come up with he's designed all of the different tests that the pilots need to take the aircraft through. So you have to have kind of some nerves of steel to do that. So I guess that they were out over the Pacific, and they're fairly low altitude, and they were coming back in towards the mountains, actually. This was in Washington State. And they lost control of the aircraft. They could not control either their direction or their altitude. And they were coming in right into the mountainside. And Glenn said that his life flashed before his eyes. They didn't have their landing gear down, of course, because they were trying to gain altitude. So they were able to gain a little bit of altitude. They flew so close to that mountain range, and I guess there were like pine trees on the top, that the trees on the top scratched the belly of the aircraft. So they actually made contact. They didn't lose control, but they made contact with the trees on the mountain that they were trying so desperately to get over. So he said that was like the most frightening moment of his life, I think, up until his diagnosis. So yeah, so that's kind of cool. Again, flight test engineer, not going to be the pilot, probably, but you'll be there in the cockpit, and you'll come up with what the test should be for the aircraft. We see these C-130s from Lockheed doing flight tests all the time over the Marietta campus. I was not, I'm from Michigan, and when I came here to interview, there was a really, really low flying. I mean, it was like at 1,000 feet, C-130. That's a big aircraft to be at such a low altitude. And it was making a really low pass by. It was loud, and you couldn't miss it. It was just right there. And I was so shocked because I didn't know that Lockheed's across the street here. I had no idea because I'd never been here before and so forth. It was just my interview at the university. And so yeah, it's kind of cool that we get to see the C-130s being flight tested. Okay, and as long as they don't lose control. Those were careers in aeronautics. Here we have careers in astronautical engineering. You could be a spacecraft engineer, so you would design satellites, probes, and human-rated space vehicles. Propulsion engineer, you would develop rockets, thrusters, and advanced propulsion systems. Mission control specialist would monitor and support the spacecraft during operations. Satellite systems engineer would create communication, GPS, and Earth observation satellites. Or planetary exploration engineer, where you design robotic rovers and landers for missions beyond Earth. Okay, so those would be the careers. All right, now let's talk salaries. Let's talk money. Aerospace engineering is paid really well. I think we don't have the data on entry level just out of school. We haven't had any graduates yet. I know that our MEs right out of school are starting about 80,000 a year. These are the average wages. I don't know. I didn't get this data, so I don't know how long they've been in the field at these salaries. This might be in the first 5 years. It looks to me like this might be in the first 5 years. Because if you go further, you would be making more. But it is one of the highest paid engineering fields. But remember, never choose your major because of the money. When I started for my undergrad, at that point, electrical was making like $5,000 more than mechanical, and I thought about changing to electrical. By the time I graduated, mechanical was making more than electrical. So any of these engineering or engineering technology fields, you're going to be making good money. And there's other things you can do to get a higher salary. One of them is to start when you already have an internship or a co-op credit under your belt. I mean credit, I mean experience on your resume. Of course, GPA, and also you might get a graduate degree, and that then you'll be making more money. If you like go into sales engineering, you'd be making a lot more money, but then again, you might be out, traveling 3 out of 4 weeks, which can have it. You kind of make more money because it's a hardship pay because it's a lot of people don't like being gone 3 out of 4. Some people might like it being away from their families for 3 out of 4 weeks, but a lot for most people that would be, a sacrifice. But so never choose it because of the salaries. Choose it because of what interests you. And all of these majors are in demand. If there was like a major where the demand was super, super low, I'd say, oh yeah, don't just avoid that one. But that's really not the case with all of the majors that are being taught in the college. So like what interests you the most is what I find that what interests me, I have the highest aptitude for. Because, I think that interest helps you motivate you to learn. So, okay, now let's talk about aerospace in Georgia. Okay, they are the number one aerospace engineering related products are Georgia's number one export. It drives the state's economy as the second largest manufacturing sector. Over 200,000 Georgians power the aerospace industry with their skills and expertise in the state. It ranks 7th nationwide in Department of Defense aerospace spending. The DoD, that would be the federal spending. And then you've got all of the private spending as well. That'd be like Boeing and SpaceX and those companies. Lockheed, all those companies, although that's closely related to DoD, Lockheed is. Since 2015, more than 40 aerospace facilities have launched or expanded operations in the state. So it's huge and growing, which is kind of a good place to be in. And they're really looking for engineers. Actually, that's true of all the engineering majors. Employment, internships, and co-ops. So all of these companies, these are the biggest ones that I thought you'd have like name recognition. There are over 800 aerospace related companies in Georgia. These, have the most name recognition: Lockheed, Delta, Gulfstream. I like this logo, Pratt & Whitney, dependable engines. The U.S. Air Force, Boeing, Archer, Northrop Grumman. So you probably know many of these, and but there's actually over 8. I couldn't fit them all on the screen. There's over 800 related companies. So there is, massive employment, internship, and co-op opportunities. Student organizations. So as you might imagine, AIAA, we have a student chapter. Again, that's American Institute for Aeronautics and Astronautics. That is the premier aerospace engineering professional society. You guys should all join, and you can have it on your resume that you've been regardless your major. Join your your intended majors professional society. They all have student chapters here. To join the society, it's cheap. It's maybe $10 a year. Often it's free. It looks so good on your resume. So we have that. We have the aerial robotics competition team, and we also have the rocket propulsion team. Okay, facilities. We have pretty amazing facilities. We have a gas turbine analysis tool, a wind tunnel, a flight simulator. As a matter of fact, I think that's the old one. The new one, I don't know, maybe that's a picture of what the new one will look like. There's a new one that's being installed this semester. We have long-range airplanes, heavy lift drones, and a wind turbine model. Okay, so if you want further assistance, where do you go? Well, obviously, you're going to start with academic advising. So Kavisha Covington and Jate Franklin, they both take aerospace engineering. And the director of advising, Jessica Martinez, she's awesome. You can go to her. And then as far as a faculty member, the aerospace coordinator in our department is Dr. Taraj Ashuri. And his office, I can actually see it from mine. It's right in the main ME department suite office area. And you'll find that he's great. You can contact him anytime. They all are really. Okay, so this is everything we talked about. I hope I answered your questions. If you have questions, of course, just contact me, Laura Ruhala. You can Google me. Or come by the ME suite, first floor on the in the tech center Q128. And in this office, there's me, there's Dr. Vize, he's a faculty member, Dr. Ashuri, I'm assistant chair of ME. Dr. Ashuri is the coordinator and associate chair for Aero. And then Dr. Suklal is our interim chair for the department. But it's just and Holly Davis is our office manager. She's awesome. We're going to be hiring a second office manager. Hopefully she'll be great too. But it's just a really friendly place. Okay, so I hope you enjoyed the presentation and feel free to contact me. Sharing and then stop recording. Bye, everybody.